A person sitting on the top of a tall building is dropping balls at regular intervals of 1 second. Find the position of the third, fourth, and fifth ball when the sixth ball is being dropped. So the question is asking, when the sixth ball is being dropped, you need to determine the position of the third, fourth, and fifth ball. So let us start solving the question in this way. So we can say that this is the tall building which the question is talking about. And the ball is released in successive interval from this position. So now the sixth ball is being released and we are asked to calculate the position of fifth, fourth, and third ball. So the fifth ball has traveled for the least duration, that is for 1 second. If the sixth ball is being released, if this is the sixth ball, then the fifth ball must have traveled for 1 second time. So this is the fifth ball. So we are calculating the position for the fifth ball first. So we are taking the acceleration due to gravity as 9.8 meter per second square. Now since the ball is being dropped, so I take u equal to 0. And since the A is acting in the downward direction, so we are taking the sign of G as minus 9.8 meter per second square. And the displacement we are going to obtain will be in the negative aspect, since it is also in the downward direction. So we are writing it as minus h. So I am obtaining a general formula for the distance traveled as S equals ut plus half at square. And we obtain it as minus h equals ut 0 minus half gt square. So we obtain that the distance traveled, or h, is going to be half gt square. So if we put 9.8 over there, we can write as 4.9 t square. So we are getting a function h equals 4.9 t square. Now what we need to do is we just need to put the value of time and get the position of different ball. So for the fifth ball, we are saying for the fifth ball, it have traveled for a duration of 1 second. So if it have traveled for a duration of 1 second, so we are going to write it as 4.9 into 1 square. So it have traveled a distance of 4.9 meter from the top of the building. For the fourth ball, we are saying that it have traveled for 2 seconds and we are going to write it as 4.9 into 2 square. So 4.9 multiplied by 4 is going to give us 19.6 meter from the top of the building. And the third ball have traveled for a duration of 3 seconds. So it is going to be 4.9 into 3 square. So it is going to give us 9 times of 4.9, that is 44.1 meter. So if I draw this in the diagrammatic way, so the fifth ball have covered the least distance, the fourth ball is somewhere here, and the third ball will cover much larger distance. So let us understand it like this, that the third ball will be somewhere here. So the distance is continuously increasing. So the balls will not be at regular interval. So in case a pictorial question is asked, so you be prepared for the pictorial question as well, that the balls are not going to be in regular distances with each other. They are at irregular distance from each other because they are following a function of t square. So let us move to the next question.